In Chapter 7, we are going to start making some inferences based on single samples here. So looking back just a little bit, populations are characterized by parameters, and then we can make decisions about parameters from looking at sample statistics here. But then inferences on parameters are going to have uncertainty, and that can be seen in the sampling distribution of that statistic. So the values of that sample statistic are distributed. They're not all the same. Some of them are far off from the middle of the distribution in lower frequency than towards the center, at least. Now, looking ahead, we're going to use a single sample to estimate a population parameter. And then we're also going to find an interval that contains that parameter. That's called a confidence interval or an interval estimate. And then we're going to use that sampling distribution of this statistic to find the reliability of our estimate. So that's the connection. Sampling distribution is connected to the reliability of the estimate. So let's talk about targets here for a second. So we're going to find an interval here around x bar, the sample mean, in which the population mean must lie with a certain level of confidence. That interval is going to be called a confidence interval. So we first start with a point estimate. So a point estimate of a parameter is a single number that estimates that population parameter. So for example, x bar is a point estimate of mu, sample mean of population mean. Sample standard deviation S is a point estimate of the population standard deviation sigma. And then p hat, the sample proportion, is a point estimate of the population proportion p. So these interval estimates or confidence intervals are actually just going to be a formula here that uses sample data to find an interval that's going to contain our target parameter, whatever it is. Most of the time it's going to be mean or proportion. And they're going to have the form point estimate plus or minus a margin of error. And then the confidence coefficient is denoted by 1 minus alpha. That's the probability that a confidence interval contains that target parameter. And then the confidence level is the confidence coefficient expressed as a percent. So 0.99 could be a confidence coefficient, 99% could be a confidence level. And it represents the proportion here of intervals that are expected to contain that parameter. If we do a large number of samples and then generate intervals from them. So we denote that confidence level 1 minus alpha times 100%. So for example, a 95% confidence level, which corresponds to alpha is 0.05. We will see a little bit more with alpha later. What that means is that 95% of samples generate, confidence intervals or interval estimates that contain the population parameter, whatever that may be. So notice this is a probability statement about the proportion of intervals that contain that population parameter as opposed to one single interval. So those are very closely related ideas, but technically the confidence level refers to the proportion of intervals that would contain our population parameter, not the probability that any one given interval would contain the population parameter.